Hello, everyone, and this is our final group presentation. This group presentation is going to be by me, Azan Fada, and Nicholas Seda, and we are going to be talking about AWS, or Amazon Web Services, here today. Understanding AWS. Amazon Web Services, or AWS, is Amazon global cloud computing platform. It provides a wide range of services, including computing power, storage, networking, databases, artificial intelligence, and many other solutions. The platform is built on three key features: scalability, elasticity, and pay as you go pricing. Scalability means resources can grow as needs expand. Elasticity means systems can adjust automatically to fluctuations in demand. And the most important is pay as you go pricing, which allows organizations to avoid large upfront costs for hardware and only pay for what they use, something that AWS was extremely revolutionary for. AWS has become central to innovation across many industries. Beyond the technology sector, healthcare, finance, entertainment, manufacturing, and many more industries have used it to improve their operations, accelerate the researching, and to reach global audiences. Um, there's a reason that AWS is considered a critical foundation of modern technology, and it's because of all of their abilities to be able to build on their key features and how useful they are for any situation instead of just being a completely technology based company. Now we'll talk about the relevance of engineering here. For engineering, AWS provides access to high performance computing without the need for expensive local hardware. This makes it possible to run design simulations, test prototypes, and perform complex analysis much faster and at a much lower cost. Collaboration is another key benefit. Teams in different parts of the world can work on the same models, share real time updates, and coordinate projects much more efficiently with a unified cloud environment. Alongside that, AWS supports infrastructure as code, which allows engineers to define and manage their systems through code rather than manual processes and much more in, much more in-depth, harder situations. Combined with automation, AWS reduces human error and makes workflows much more consistent and efficient. All in all, AWS helps engineers move from concept to prototype faster, improves teamwork, and streamlines system management for all. Applications and impact. There are many applications for AWS, a lot of that being smart manufacturing, generative AI for product design, healthcare, smart cities and autonomous vehicles, and some societal impacts are faster innovation, lower cost, global accessibility, and some risks in regards to the societal impact are data privacy, energy use, dependency on cloud providers, and more. To start, AWS is being applied across industries in ways that directly affect society every day. In manufacturing, it enables predictive maintenance and real time monitoring of equipment. In product design, generative AI tools on AWS assist in creating and testing ideas virtually. In the healthcare industry, organizations use AWS to analyze genomes and accelerate drug discovery, cutting down processes that once took years and years and years. AWS is able to speed it up in just the slightest amount. On a larger scale, AWS supports smart cities and autonomous vehicles by handling the massive amounts of data these systems can generate. While the benefits are extremely significant, these there are challenges as well when it comes to AWS, such as data privacy concerns, the environmental impact of large data centers, and risks of dependence on few cloud providers. Obviously, faster generation, lower costs, and global accessibility has been huge for AWS in allowing them to be able to grow and for many people to be able to access AWS. And overall, AWS expands access to advanced technology, accelerates innovation, and reshapes and actually does reshape how industries approach problem solving on a worldwide scale. And finally, I'll be talking about how we used MS Teams. In preparing this project, MS Teams was our primary collaboration platform. We used it as our main form of communication. We used it to share documents and slides within a centralized channel. This always made sure that everyone had access to the most updated materials. The chat function was extremely helpful for us as it allowed us to communicate efficiently, and we did not have to send emails to each other and have lengthy email exchanges, and instead we were able to just get quick feedback with just quick messages, and were able to problem solve together. Teams also helped us manage responsibilities by using tasks lists, and if we ever did need to meet with each other, have shared calendars to track progress and deadlines. By communication, it acted beyond communication, it acted as a single hub for all project resources. We were able to share slides, notes, and the research we conducted all throughout Microsoft Teams. This eliminated the need to search between multiple tools and different platforms for all of our information. We were able to create a more streamlined and organized workflow, which made collaboration much more effective. All in all, Teams provided the structure and accessibility needed to keep our group coordinated and allow us to be as efficient and productive as possible from start to finish. Now I'll pass it off to Nicholas Seda as he will continue this presentation.
Thank you, Azan. Next up, we have some issues encountered in engineering. Amazon Web Services, also known as AWS, does present a handful of issues that should be considered before an organization elects to make proper use of it. Among those, for example, we have complexity. AWS is a distinct data and computation environment with its own specifications that requires a certain level of expertise to make full use of the platform. A company should therefore take this into account and ensure that they have the requisite ability for the service, whether this means hiring new staff or more training or even communicating with subject matter experts. There's also integration and adoption. Using AWS necessarily requires transferring potentially very large amounts of data from in-house solutions to AWS systems. This may result in a variety of problems, from intellectual property concerns to large alterations to, as Amazon puts it, existing workflows, processes, and cultures. Migration strategies should be carefully adopted to ensure seamless adoption of AWS as a whole. Next up, we also have business scaling. Companies that want to make use of AWS must consider long-term scaling and ensure that their business models align with the scalability and built-in technologies of AWS. If a business wants to scale up, they should be expected to, as I'm about to mention, pay a higher cost. So next, of course, cost. AWS does have its own cost estimation programs that companies can use to determine the expected overhead fees associated with the service. It is a pay-as-you-go service, so this is rather useful for them. But they still need to keep in mind that appropriate budgeting is an ongoing process. Proper forecasting, especially in the case of scaling, is necessary to avoid potential financial problems such as unexpected cost spikes, where resources are overused and Amazon bills them therefore, and resource underutilization, as Amazon puts it themselves, which would be cases where they don't use what they've paid for properly. Moving on from there, we do have a couple ethical issues to consider. Ethics is a common concern for customers of Amazon Web Services, also known as AWS. While they do generally have very transparent pricing models and consumer-centric service offering, according to a public conference paper by Yusuf Ricky Carroll at Oxford University, the Ethical Consumer Research Association has a slightly more pessimistic view. um, claiming that Amazon is known to undergo many ethical challenges, including tax policy practices. Amazon is known to have avoided many tax payments through an array of tax haven loopholes, including UK tax credits, despite continuous profit increases over recent years, especially since the recent pandemic. Environmental policies should also be considered. Additionally, Amazon has been documented as underreporting their greenhouse gas emissions by selectively choosing the sectors that they measure and ultimately report on. This, in addition to the high electricity demands of their systems, which shockingly account for about 1% to 2% of the entire global electricity demand, and that is only supported by about 22% renewable sources, the company's carbon footprint, therefore, is ethically dubious at best. There are also some additional ethical issues that are rather universal to almost any cloud computing solution, such as AWS, and so we should consider those. Most importantly, data security risks. AWS and similar platforms handle vast amounts of user and company data, and therefore are a potential liability in the case of security breaches and data breaches, which should be avoided at all costs. We also have vendor locking. Vendor locking is a situation in which a company is forced to continue using a certain service due to organizations' dependence on the cloud computing and built-in systems of AWS, which is encouraged by Amazon, and similar services. Organizations may risk great detriment to their overall revenue if they seek to separate from the cloud computing service itself. They would need to front the necessary fees to accommodate their own computing systems and invest large amounts of time in the effort of moving their product out of AWS systems. Okay, moving on from there, we have challenges and opportunities. As we've gone over extensively, Amazon Web Services is a very extensive platform with many capabilities. Conveniently, Amazon has published many documents and prescriptive outlines, as they put it, relating to their product, especially in regards to various challenges and opportunities afforded to AWS. The challenges that Amazon recognizes stem primarily from the cloud environment of the application and do consider the business goals of organizations that may use AWS. These are making full use of cloud benefits. A very important thing to anybody who would like to use the cloud is making full use of the benefits. Reducing time to market, and in this case we'll go ahead and mention that benefits such as agility, reliability, and scalability, according to Amazon, are important factors to most any company and are much more accessible via the continuous development structure of the cloud and its built-in, or as Amazon puts it, cloud-native services. On that note, reducing costs is also a strong opportunity. Many companies, including Charlix, whose logo is in the corner, a private security company, have used AWS to reduce overall operating costs. According to Charlix, AWS allowed them to modernize their architecture and facilitate the daily processing of terabytes of security data while reducing related costs by about 35%. Quite a significant bonus. Cloud operations do, however, require frequent maintenance. Amazon does admit that cloud-centered products do have certain maintenance requirements that need to be accounted for, such as monitoring, incident and problem management, patching, backups, and security management, according to Amazon. Each of these elements need to be consistently worked on, which may limit an organization's ability to focus on the actual product development itself. Mitigating this downside is a hurdle that companies using AWS must learn to overcome. Last up here, we have the challenge of recruiting cloud talent. As with any platform or framework, it is important for companies to hire and or train staff that is well versed in the platform specifics and best practices. We went over this about a slide ago. Failing to maintain best practices while using AWS may expose a business to security vulnerabilities, another problem from the previous slide, and significant lost time as a result. Okay. Now, additional resources. Amazon is very transparent in a lot of their documentation, so they have provided two different but similarly gold sources to further look at their information. AWS.Amazon.com has a prescriptive guidance section that gives solutions for many specific problems, and the documents, docs.aws.amazon.com, supplies many more specific, detailed documentations of the various capabilities and methodologies of AWS. Since ethics was also a major concern, I've also included a link of that through the ethicalconsumer.org page for AWS. That should be considered, especially for any company seeking to use AWS. Now we have a couple of questions for the audience. 1. What function does AWS serve in a business environment? 2. What are some common applications of AWS? 3. What is a potential issue of AWS adoption? 4. What are two noteworthy ethical issues with AWS? And 5. What is a significant opportunity associated with AWS? Thank you very much. I hope you enjoyed.
Alright, what's up, guys? My name is Tycho Collins, and I am part of Group 3 for the presentation. And in Group 3, we chose two topics. We done AWS as the first topic, and AI and its impact on society as the second topic. And alongside my group members, me and John Cosby, we worked on AI and its impact on society. Alright. So before we get started, I'm pretty sure all of you guys have a basic understanding of AI and artificial intelligence. I'm sure a lot of you guys have used AI to ask questions, get better understanding of things. You have a lot of AI tools that are at your disposal for free online. You have a lot of things that can create images such as Midjourney, Grok, Gemini, and also you have AI prompts you can use, language learning prompts such as ChatGPT, Grok, and Gemini. You can use all of them to ask questions and find solutions. So, overview of AI. AI, artificial intelligence, is a simulation of human intelligence by machines. These can be done through machine learning and high-tech computer systems, allowing the AI to think and act like humans. AI is a super intelligent system that can define the future of human civilization. Now, we can see that AI is a machine learning model that we believe can be the future to our human civilization. And nowadays, a lot of big companies, massive companies, are spending a fortune, billions and billions of dollars on the development of AI. Big companies such as Meta by Mark Zuckerberg, Grok AI by Elon Musk. You have ChatGPT. So it's a multi-billion-dollar industry, and we believe that AI, artificial intelligence, is the future. So moving on, this is an incredibly significant, and it could be the biggest achievement in the 21st century. With the use of AI, we can have machines capable of handling processes and workloads for humans, essentially doing the work for humans and creating breakthroughs. So basically we have, in the first slide, we get an understanding of how AI works, how important artificial intelligence is, and it could be the biggest achievement in the 21st century. Moving on. So, relevance of engineering design and process. Currently, AI is an important process in the engineering and design processes. Engineers are using AI to help with specific tasks in their work. AI is being used to optimize designs, performance simulations. AI algorithms are a cost-efficient solution that reduces manual labor. There are many different ways and solutions that AI can provide for humans, all while processing data and information at incredible speeds. So, example of how an AI can be a cost-effective solution that reduces manual labor could be the factory example. Let's pretend that you're working at a factory. There are many hard processes and manual labor processes, such as a work line. You have a line of workers that are assembling parts. You could replace them with a robotic arm or AI arm and have them do this manual line work in the factories. But in the factories, you also have many tasks such as moving heavy boxes, heavy loads, which is a lot of stress and a lot of manual labor, which you can also replace with the use of AI and robotics. You could have robots and AI carry the heavy loads for you, so that reduces the human labor, and that would be a very good solution. And so, yeah, besides AI being able to optimize design, performance, and simulation, that really the plan is for them to be an effective solution that reduces manual labor as well. So moving on, um, okay, how and where issues are encountered in the engineering profession. In the engineering process and profession, issues are encountered in all parts of the profession, including technical challenges that may arise, ethical challenges as well. In the profession, engineers are made to solve problems. There are many problems encountered through various projects that may need to be solved and figured out. It is part of the engineering process. Engineering is about problem solving. So, to give you guys some examples on where problems may arise, um, you could find in the engineering process there are requirements and specifications that may have some issues in them. You got design and analysis, where you could also find issues and encounter problems in the design and analysis. Also, materials manufacturing, cost, factory, finding the right factory, supply chain. That's also an issue. You can also have operation and maintenance issues, and yeah, just a lot of issues that you're going to be encountered in engineering, and that's why as engineerings we're made to solve these problems. So yeah, and to give you guys a little bit more idea of how AI and their application works, going back to overview, I want to give you guys a few more examples. So with AI and applications, we got search recommendations, which is basically machine learning and deep learning technology. That's ChatGPT, Google search, all the search recommendations that you use. You have generative AI, which is basically it generates images and videos. You guys have ChatGPT, Midjourney, and Gemini to generate images. That's part of the large language models. You have digital assistants such as Siri, Alexa, Google Assistants. That's part of the natural language processing. Um, and yeah, you just have a lot of different use cases for AI and different application fields as of right now. So yeah, these were the slides that I worked on, and I will bring you guys to John Cosby to finish the presentation on.
Hello, my name is John Cosby, and I will be speaking about AI and its impact on society. My partner, Tycho Collins, has covered the first several points in this subject, so I'll be speaking about the remaining few points. How and where issues are encountered in the engineering profession. So regarding AI. Engineers face AI challenges at every stage of development. Early phases often involved unclear goals, data issues such as bias and privacy, and design problems like brittleness and weak explainability. Verification is hard because AI can behave unpredictably, while deployment requires monitoring, handling model drift, and reporting incidents. Governance adds further demand through documentation, audits, and cross-team coordination. Real quick, I will say that I've had some experience with this, as I'm sure many students have, especially in the computer science department. I find that often. I mean, I have used some AI to try to generate some code before, and whereas a lot of times the code may function to some extent, it's usually not optimal. There usually are issues, and a lot of times it ends up being even more work to try to get an AI to generate a code to do exactly what you're trying to do for your specific uh, whatever you're specifically trying to develop. That it's obviously more beneficial just have a strong understanding, a strong foundation of coding and being able to write that self. And if you want to use it as a tool to kind of have like a skeleton of a code or kind of like point you in the right direction, that can be beneficial. But there certainly are some issues encountered if you're just trying to rely solely on AI for something like that. Uh, these issues are most critical in high stakes fields. Healthcare requires strict life cycle evidence and control of updates, while automotive systems must meet safety standards like the ISO 26262 and SOTIF. Infrastructure projects face liability under the EU AI Act, and software engineers deal with the risks such as insecure AI generated code, like we were talking about. To address these challenges, standards like the NIST AI Risk Management Framework, ISO IEC 42001, and the EU AI Act provide essential guidance. And we'll talk a little more about what those are later. But yes, obviously, you know, for for something like in healthcare or in the automotive field, if you're using AI and there's a risk there, and then it's not just a risk to you, you're putting other people at risk. If a doctor or a surgeon's using AI, I don't know how exactly, but once you've taken it to that level to where people's lives are at stake, like in healthcare and automotive, you're it becomes so much exponentially riskier as you go. Ethical issues concerning AI. So this kind of goes along with the same subject. AI raises significant ethical challenges across its development and use. Common issues include bias in training data, which can lead to unfair treatment or discrimination, and a lack of transparency, which makes it difficult for users to understand how decisions are made. Privacy is another concern, as AI often relies on large amounts of personal data. Accountability is also unclear when AI systems make harmful or unintended decisions, leaving engineers, companies, or regulators to determine responsibility. These ethical concerns are especially important in sensitive areas in healthcare, like we were speaking about. Biased algorithms, biased algorithms can affect patient diagnosis and treatment. So very obvious to see where the ethical gray area is there. In hiring and education, AI tools risk reinforcing inequality if they reflect societal biases. Surveillance systems powered by AI raise questions about civil liberties and consent, while generative models can spread misinformation or harmful content. To address these challenges, frameworks like the EU AI Act, UNESCO's AI ethics recommendations, and guidelines from groups such as the IEEE provide direction for ensuring fairness, transparency, and accountability in AI systems. Challenges and opportunities with AI. AI brings both challenges and opportunities for society and engineering. Key challenges include the displacement of certain jobs, the difficulty of regulating rapidly advancing technologies, and the technical limits of explainability and safety. Security risks such as adversarial attacks and misuse also remain major concerns. on the organizational side, the high cost of infrastructure and the need for skilled talent can slow adoption. These hurdles make it essential to balance innovation with strong governance and continuous oversight. And this is also something that is talked about quite a bit in the computer science field, where a lot of programmers, a lot of developers are either not being hired or being just outright replaced by AI, by maybe people who don't have a strong understanding of coding or computer programming, and they think that, the AI can just generate the code just as well as a trained programmer, which is not the case. I know firsthand that is not the case, as many do. So I'm hoping in time that this will become more common knowledge and more companies will realize that AI, at least right now, is not up to par with a skilled programmer. Now, there is some concern, AI is always advancing, so in the future, maybe it will be. Who knows? I mean, in all likelihood, it probably will be someday, but right now it's not. So just getting rid of all your developers and replacing them with AI is a recipe for disaster, in my opinion. But it's happening a lot in the industry. Anyways, at the same time, AI offers significant opportunities. It can boost productivity, improve healthcare outcomes, and enhance safety in areas like transportation and infrastructure monitoring. In education, AI can personalize learning, while in business, it can streamline operations and open new markets. AI also supports advances in scientific research, accelerating discovery in medicine, climate modeling, and materials science. With proper policies and ethical frameworks in place, AI has the potential to drive innovation and growth while addressing pressing global challenges. And so, yes, obviously AI is an incredible technology and makes a lot of uh, different parts of businesses like extremely efficient, more efficient than humans could ever be. So there's some give and take there, and I certainly would see the appeal. Not to mention how much money a lot of companies can save using AI for not having to hire programmers and artists or whatever else it may be. I could certainly see the incentive for a company to want to just rely on AI, but I think there are some obvious pitfalls if you were to do that. All right, some resources to learn more about AI. I found a few books and articles here. Atlas of AI, Power, Politics, and the Planetary Cost of Artificial Intelligence, The Alignment Problem, AI Ethics, and then just a textbook on the ethics. And if you want, I actually link some Wikipedia articles about these. If you want to get some more information about the information, you could view those as well. Some questions for the audience. What are some of the main challenges engineers face when developing and deploying AI systems? Which high-stakes domains face the most serious risk and why? What ethical concerns arise when AI relies on biased or sensitive data? How do frameworks such as the NIST AI Risk Management Framework and so on, etc., help address the AI challenges? And I actually haven't given that one yet, but we're going to talk about that in just a second. And what are both one major challenge and one major opportunity AI creates for society? So I was going along reading about all these risk management frameworks, acts to help with AI and mitigate risk. And so I looked into what some of that was, and I'll show you here. There's a few different ones. This is what the European Commission AI Act. And I didn't look super deep in depth with it, but basically it looks like they are trying to um, mitigate risk and depending on what the circumstance is. So like there's 4 levels of risk: unacceptable risk to minimal risk. Some professions maybe can have a limited risk, whereas some professions like healthcare or automotive, you need to have minimal risk or no risk. So this is like an act to try to figure out and try to limit the risk for those professions and find the best way to do that. And there's a few different governing bodies that are working to try to do that right now, which is probably a good thing, probably a good idea. All right, so that is my presentation. Thank you for listening, and you have a great day.